1895. A creek bank in western Kansas, cut open by erosion and curiosity. Scientists kneel in the mud, and there it is, a stone point, wedged beneath the shoulder blade of an animal extinct for 10,000 years. The first proof, ever, that ancient hunters killed Ice Age bison in North America. It happens 30 years before Folsom, the discovery that gets all the credit instead. Then the point vanishes, stolen, gone. For decades, scientists called it Clovis, America's first culture. But the dates say otherwise, and the proof of where those first people came from was buried elsewhere. Picture the scene a little closer. 12 Mile Creek, a narrow tributary of the Smoky Hill River, cutting through the dry, wind-blown plains of Logan County. Bison teeth poking out of an eroded creek bank in the middle of nowhere, catching a local landowner's eye. Word reaches a team of scientists at the University of Kansas. What follows within days is one of the earliest scientific excavations of its kind on the continent. Careful notes, a photograph, a young science trying to prove something almost nobody believed yet, that people and mammoths and giant bison had shared the same Ice Age world in America. Today, that same stretch of ground sits inside a nature preserve, quiet, grazed by wind and cattle giving no hint of what was pulled out of it. If you've never heard of 12 Mile Creek, that's exactly the mystery worth chasing. Why did the site that got there first end up forgotten? Here's why that matters. Before this creek bank in Logan County, no scientist anywhere in North America had proof, real physical proof, that humans and Ice Age megafauna occupied the same moment in time. Not a legend, not a folktale passed down through generations. A weapon, still lodged in bone, exactly where it landed. University of Kansas paleontologists Handel Martin and T.R. Overton pulled it from the dirt in 1895, working for a museum that still displays the bison today. 12, maybe 13 animals, depending on which study you read. Butchered, their bones scarred with cut marks. Driven, it appears, into a ravine and killed there in a single coordinated hunt, frozen in sediment for 10,000 years, waiting. This should have been the discovery that changed everything we thought we knew about the first Americans. It wasn't. 31 years later, in 1926, a ranch foreman near Folsom, New Mexico, found something almost identical, a point buried with extinct bison bone. That discovery became famous. Textbooks, museum wings. A turning point in American archaeology, the moment the scientific world finally accepted that humans had walked this continent alongside animals that had been extinct for millennia. 12 Mile Creek became a footnote, cited occasionally, argued over quietly, never celebrated. Same kind of evidence, same kind of animal, same continent. So why did one become legend and the other get buried in academic journals nobody reads outside a university library? The answer is uncomfortable, and it starts with what the excavators actually did and didn't do in 1895. When the Folsom team found their point in 1926, they stopped digging. They called in outside experts, geologists, paleontologists, people with no stake in the discovery, and let them independently confirm that the artifact and the bison bone were locked together in the same undisturbed layer of earth. That single decision is why Folsom became the moment American archaeology accepted that humans had hunted Ice Age animals on this continent. It wasn't just about what they found. It was about who was allowed to check their work. Nobody did that at 12 Mile Creek. Martin and Overton excavated, photographed, and published through their own institution, with no outside verification, no independent witnesses standing over the trench. The site's discoverer, paleontologist S.W. Williston, wrote it up for a geology journal in 1902, then again in 1905. And then, almost as if the story wanted to disappear on its own, the artifact itself vanished, stolen, sometime shortly after the dig. No suspect was ever named. No recovery was ever made. No explanation survives in any record anyone has found. Which means everything scientists have argued about this point for over a century comes down to one surviving image. A photograph published by Williston in 1905, grainy even by the standards of its time. That photograph is the entire case file. No modern scientist has ever held the object, tested its edges under magnification, run isotope analysis on its surface residue, or compared it side by side with a verified Clovis point from another site. It's a ghost with a paper trail, and the paper trail is thinner than it should be for a claim this important. And here's where it gets stranger. In 1984, researchers named Rogers and Martin, a different Martin, generations removed from the original dig, went back to the case. They looked at that same blurry photograph and confidently called it Clovis, the fluted point style associated with what was, at the time, believed to be the very first culture in the Americas. A single sweeping identification made from a photo of a stolen artifact nearly 90 years after the fact, describing a concave base and a faint flute that no living scientist has ever confirmed with their own eyes. But their own paper contained the seed of its own contradiction, because when they radiocarbon dated the bison bone, the point had been found beneath. The dates didn't fit the story they just told. 2 radiocarbon results came back from a single bison tibia, one around 10,245 years old, the other around 10,435. Translate that into calendar years, and 12 Mile Creek lands somewhere around 12,000 years ago, squarely in Folsom territory. Not Clovis. Clovis technology, according to the most precise dating done decades later by researchers Michael Waters, Thomas Stafford, and David Carlson, existed in a startlingly narrow window, roughly 13,050 to 12,750 years ago. A window of about 300 years, a blink in geological time. 12 Mile Creek's dates fall outside it, on the younger side, in the era when Folsom points were the tool of choice on the plains. Rogers and Martin admitted it themselves, in their own words, calling the mismatch surprising. Later researchers went further. Kenneth Brown and Brad Logan of the Kansas Geological Survey concluded the site couldn't be confidently placed in the Clovis category at all. More likely Folsom, or something transitional between the two. Waldo Weddell, one of the most respected plains archaeologists of the 20th century, said the point simply didn't match any recognized early type. Not Clovis, not Folsom, not any of the named Ice Age styles scientists used to sort the plains record. So the label everyone still repeats, Clovis, may be wrong, not because someone lied, because a photograph of a stolen artifact was asked to answer a question it was never equipped to answer, and the answer got printed anyway. And that raises an uncomfortable question of its own. Museums build reputations on their type specimens. A site that gets labeled first or earliest draws funding, footnotes, prestige, and a permanent line in the textbooks. Once a label like Clovis gets printed in enough guidebooks and repeated in enough classrooms, changing it isn't just a scientific correction. It's a quiet admission that the story sold to the public for 40 years might need a rewrite. Nobody in Lawrence, Kansas benefits from making that case loudly, so the label stays on the wall unchanged, while the actual debate plays out in journals almost nobody outside the field ever opens. But that mismatch does something more important than embarrass one Kansas site. It forces a bigger question into the light. If 12 Mile Creek isn't proof of Clovis First migration, what actually is the proof? Where did the first Americans really come from? And how do we know? For most of the 20th century, the answer was simple, almost elegant. Ice Age hunters crossed a land bridge from Siberia into Alaska, then funneled south through a gap between 2 massive ice sheets, the so-called ice-free corridor, arriving on the Great Plains roughly 13,000 years ago as the Clovis culture, then spreading across 2 continents in a matter of centuries. Clean, linear, textbook. For decades, it was treated less like a theory and more like a wall nobody was allowed to cross. Then, the ground itself started talking back. In Chile, at a site called Monte Verde, archaeologist Tom Dillahay uncovered human occupation dated to roughly 14,500 years ago, 1,000 years before Clovis even existed, on the wrong end of two continents for a corridor migration to explain. Preserved wooden stakes, hide fragments, even a child's footprint survived in waterlogged peat. It took years and a personal site visit by skeptical outside archaeologists in 1997 before the mainstream finally accepted it. In Florida, underwater in a sinkhole called Page Ladson, researchers pulled a butchered mastodon and stone tools dated to about the same age, using more than 70 separate radiocarbon samples to nail the timeline down. In Idaho, at Cooper's Ferry, archaeologist Lauren Davis found tools resembling artifacts from late Ice Age Japan, dated to nearly 16,000 years old, predating not just Clovis, but the opening of the corridor itself. In Texas, at the Buttermilk Creek site, more than 15,000 artifacts were found buried in a layer directly beneath a Clovis assemblage, dated as much as 15,000 years old. In an Oregon cave system called Paisley Caves, scientists extracted human DNA from fossilized human waste dated to over 14,000 years ago, proof of people, not just tools, long before Clovis walked the plains. And the timeline keeps getting pushed earlier still. In 2021, researchers led by Matthew Bennett published a study in the journal Science describing human footprints preserved in ancient lakebed mud at White Sands, New Mexico, dozens of tracks made by what appear to be mostly teenagers and children, dated using seed layers to between 21,000 and 23,000 years old. If accurate, that is nearly 10,000 years before Clovis. The dating method was immediately challenged. Those seeds grow in water, and water can skew radiocarbon results by absorbing older carbon from the lakebed itself. So researchers went back with a second method, dating pollen instead, and a third, dating the quartz grains in the mud directly. The numbers held. Then, in 2025, a University of Arizona team, led by geologist Vance Holliday, dated the surrounding lakebed mud itself and landed in the same range, bringing the total to over 50 separate radiocarbon dates, all pointing the same direction. Holliday put it plainly, it would take serendipity in the extreme for that many independent dates to all be wrong the same way. Not every specialist is convinced. Some still argue the results represent maximum possible ages rather than confirmed ones. But the debate over White Sands has not gone away. It has gotten harder to dismiss with every new test. For a while, all this uncertainty gave oxygen to a theory that sounded almost too strange to be taken seriously. And yet, for a decade or more, some respected researchers argued for it in peer-reviewed journals. The Solutrean hypothesis, championed by Smithsonian archaeologist Dennis Stanford and University of Exeter researcher Bruce Bradley, proposed that Clovis technology didn't come from Siberia at all. It came from Ice Age Europe. Their argument, the stoneworking techniques used by Solutrean toolmakers in what is now France and Spain looked strikingly similar to Clovis flint knapping, and both cultures existed at roughly compatible times. Their theory required something audacious, small bands of Ice Age humans crossing the North Atlantic along the edge of the pack ice, by boat, thousands of years before anyone thought humans had mastered open water travel. It was bold. It was controversial. It gave the mystery of Clovis's origin an entirely different geography. And for a while, it forced serious scientists to seriously consider it. Then the genome answered the question the stone tools couldn't. In 1968, near Wilsall, Montana, construction workers uncovered the only human skeleton ever found buried directly with Clovis tools. An infant boy about a year old, dead 12,700 years ago, covered in red ochre alongside more than 100 stone and bone artifacts. Scientists call him Anzik 1. In 2014, a team led by Morten Rasmussen and Eske Willerslev sequenced his entire genome to remarkable depth. The results were unambiguous. Anzic 1's ancestry traces directly to Siberia, and he is a direct genetic ancestor of the majority of Native American people living today, especially in Central and South America. That single result did two things at once. It confirmed the deep Asian origin of the first Americans, and it ended the Solitrian hypothesis almost overnight. There is no European ancestry in Anzic 1's genome. None. The mitochondrial marker Stanford and Bradley had leaned on as evidence of a European connection has never once been found in an ancient Eurasian sample. The theory that had sounded tantalizing for over a decade collapsed under a single DNA test. But the same genome also complicated the timeline further, because a population with roots that deep in Siberia, reaching North America with a Clovis toolkit only after other people had already been in Chile and Idaho for 1,000 years or more, doesn't fit a simple first arrival story either. Geneticists have proposed something called the Beringian standstill, a population that crossed into the land bridge region and then stalled there for thousands of years, isolated, before finally moving south. The exact length of that pause is still debated, with newer estimates running far shorter than the earliest proposals. But the shape of the answer is becoming clear. Not one clean migration, but a slow, stalled, branching movement of people, some heading down an interior corridor that geological surveys show was ecologically dead until roughly 12,600 years ago, too late to explain the earliest arrivals, and others likely tracing the Pacific coastline instead, along what researchers now call the Kelp Highway, a food-rich route that deglaciated earlier than the interior ever did. The old story said, one people, one route, one moment. The real evidence says, multiple populations, multiple timelines, and a genetic record that knows more than any single stone point ever could. But evidence like this doesn't just rewrite textbooks. It reopens graves, and it reopens arguments that have never fully closed. In 1996, near Kennewick, Washington, a skeleton nearly 9,000 years old surfaced along a riverbank, and the United States Army Corps of Engineers took custody of the remains. Early analysis described the skull as unlike modern Native Americans, and for years, that single interpretation triggered a legal war. 8 scientists sued the federal government for the right to study the remains directly, while regional tribes argued he was an ancestor who deserved reburial, not a research subject. A federal appeals court sided with the scientists in 2004, allowing study to proceed over tribal objections. It took until 2015 for full genomic sequencing, led again by Eske Willerslev's team, to settle the biology once and for all. Kennewick Man's closest living relatives are Native American, carrying the same Y chromosome and mitochondrial signatures found across the continent today. Congress passed legislation clearing the way for repatriation in 2016, and in February 2017, 5 tribes, the Umatilla, Yakama, Colville, Wanapum, and Nez Perce, buried him together in a ceremony attended by more than 200 people. The science had taken almost 2 decades to catch up to what the tribes had said from the very beginning. Anzic 1 tells a quieter version of the same story. Found on private land in Montana, his remains weren't legally required to go through tribal consultation before testing, but after his genome rewrote what we know about the peopling of 2 continents, questions were raised about whether that consultation should have happened anyway. In the end, he was reburied in 2014 in an intertribal ceremony in the Shields River Valley, returned to the ground that had held him for 12,700 years. A discovery that changed the scientific record still had to answer to something older than science, the question of who a set of remains actually belongs to. And the fight over who gets to write this history isn't finished. As recently as March 2026, a team led by Todd Suravel published a study in the journal Science, arguing that Monte Verde, one of the pillars of the entire pre-Clovis case, might actually be thousands of years younger than believed, dating closer to the mid-Holocene, somewhere between 4,200 and 8,200 years ago, rather than the Ice Age. Their explanation: the older wood samples may have washed down from ancient contexts further upstream and been redeposited at the site, tricking earlier dating efforts. Tom Dillehay and roughly 30 co-authors fired back almost immediately, defending decades of careful excavation against what they called a conclusion, reached after a few hours of fieldwork with no new digging at all. Dillehay didn't mince words, calling the challenge driven by ideological bias rather than new evidence. That argument is happening right now in real journals between real scientists, with the deep origins of 2 continents worth of people sitting in the balance, a reminder that even the most cited settled discoveries in this field can be dragged back into open dispute decades later. Which brings us back to Kansas. The bison from 12 Mile Creek still stand today, reconstructed, inside the University of Kansas's Natural History Museum in Lawrence Deitch Hall, a building full of glass cases and taxidermied history, first put on display more than a century ago. Somewhere in that collection sits the legacy of a discovery that beat Folsom by 31 years and never got the credit. The point that started it all is still missing. No recovery, no explanation, over a century later. All that survives is a photograph too faint to settle the argument it created, filed away in a journal from 1905, waiting for a re-examination that may never come. The label near the bison may still say Clovis. The dates say otherwise. And the real answer to where the first Americans came from isn't sitting in that display case at all. It's sitting in a genome sequenced from a Montana infant, in sediment cores pulled from a dead corridor and footprints preserved in New Mexico mud, in a Chilean site now caught in its own fight for survival. The riverbank in Kansas didn't solve the mystery. It cracked it open and left the crack sitting in the dark behind museum glass, a century deep and still spreading. More than 130 years later, nobody has gone back to close it.